So in this video we are going to calculate the equivalent resistance. So first step for the calculating resistance is that see the terminal where at which across we have to find the equivalent resistance. So suppose in this example we have to find the equivalent resistance across AB. So first rule is that don't touch this terminal, don't disturb this terminal, and don't forget about this terminal. If you forget, what you will do now, if you forget this terminal, these two resistors are in parallel. But if you forget this terminal, these two will be in series. You might do this kind of mistakes. So avoid it. Just stick to your terminal. Wherever you want to find your equivalent resistance, stick to that terminal. And that is we have to find a resistance across terminal AB. So we should not disturb this terminal while calculating equivalent resistance. So first part we clear about that. Wherever you want to calculate resistance, don't disturb that part. At least you should draw where you want to calculate resistance, at across where you want to draw equivalent resistance or calculate equivalent resistance. And second step is that fundamental step is that start from the end of the end part of the network. So suppose if you want to calculate equivalent resistance of this part, and here is a terminal at across you have to calculate the equivalent resistance. So start from this part, end of the network, not from the beginning part where you want to calculate equivalent resistance. So this is not the right way. You will get into some difficulty. So if you apply this kind of method, so every time you should start from the back end of the network. So you will start from this network and you will converge to the starting point. So we are taking one example. Suppose we have this network and we have to calculate equivalent resistance across this terminal, right? So first step is that don't disturb this terminal. You should be able to identify this terminal where you want to calculate your equivalent resistance. So we have terminal A and B. So you should very careful about this terminal. You should not forget, and you should start from the back end of the network. So where is the end of the network? This. So you should start, and for this if you have two similar values, if you have two equal values resistance in parallel, so there is a shortcut is that if you have two similar R equivalent value, that is R equivalent is R by 2. So suppose we are taking one example. Suppose we have parallel two resistors of 40 ohm, that will be half 40 by 22. So conventionally what you do now, 40 plus 40 is 80, 1600 and divided by 80. So what will you do? This. So it is equivalent to this. So suppose you have 10 parallel 10, you will get 10 by 2, 5. Suppose you have 36 resistor, 36 means 3 resistors which have equal value 36, 36, 36. So what you will give now? 36 by 3. So because 36 have repeating 3 times, you should divide by 3. So that is 12. Okay. Suppose we have 16 4 times. So we have 4 resistor. So you should divide by 4. That equal to 4. So if you will do calculation also now, that will give you same result. So this is the shortcut of the equivalent resistance. You should calculate like this. And so we are coming back to our example. So we want to calculate our R equivalent. So suppose 10 parallel 10. What is that? Two resistors are parallel in similar. So 10 by 2, that is 5. And this resistor will be in parallel. So 30 plus 5. So that is 35. Now 40 ohm parallel 40 ohm 2 times. Okay. So we should divide by 2. That is 20. Because these resistors are similar. And 35. Now 35 and 20. These resistors value are not same. So what will you do now? You will follow conventional method. 20 into 35 divided by 20 plus 35. That is I'm not calculating. I will denote at X equivalent. Okay. So now coming to next part. So we are not disturbing terminals in this whole process. We are not disturbing our terminal. We should not disturb our terminal. That's the main fundamental rule. So this X equivalent will be in series of 3 ohm. So 3 plus so equivalent resistance of 3 plus X equivalent is 3 X equivalent, and this X equivalent, this whole resistor will be in parallel of R1. So across this you are getting R1 parallel this resistor. So if you calculate value of X equivalent, just put into this, you will get the answer. Okay, so this is the easiest step to find equivalent resistance. So I hope you got it, and you will be not find any difficulty to finding equivalent resistance.